I've done all the required things.
The light is on.
Yeah, it says live.
Hi everyone.
So I'm.
Oh, okay. Now you're gonna
Oh,
do. Now you're gonna do what I do normally.
Am I?
Yeah.
Oh, yeah, I am. Wait. Okay, so is this a totally reverse show? Or are you going to? Why don't you give the intro? You gotta guess. You have to say something about dearies.
I have to say something. What?
About dearies, like hello dearies.
Do I know? Isn't that your catchphrase? I feel like that's your.
Oh, I thought it was our catchphrase.
I don't have any catchphrases, as far as I know. Maybe I should get one.
Now is your opportunity. This is the start of something new.
Hello, darlings. Welcome to Undersampled Radio. It's episode 74. Of course, I meant dearies. In case you're confused, this is Undersampled Radio. And it is episode 74. And today we have with us Eirik Larsen, who is in Norway. He's CEO of Earth Analytics. We'll be chatting to him. We'll wave at you for now, Eirik. Please feel free to chip in or interrupt if you want to. Graham.
Yes.
What's going on, man? You're in some kind of cool-looking TARDIS-like space cupboard.
I am. I'm in my command center here at Expiro in Austin.
Very nice.
I'm soliciting better names than command center, but so far, all that's happened is someone put a command center label on the door with a label maker and a slidable vacant or open little thing like you'd see on an airplane bathroom.
Okay.
Which is about as nice as this. This is.
So we're inviting punny combinations of Undersampled Radio, command center, cupboard.
That's it.
Matt, do you know what I mean by cupboard? Is a cupboard a thing? I guess I mean closet, do I? Or
pantry, maybe?
Pantry.
Mm-hmm.
Okay.
Mm-hmm.
This is the smallest room in Expero, probably.
You have a lot of stuff on your news list. So I'm going to...
Yeah, why don't we do yours first?
Yeah, let's do mine first. Okay, I only have 2 bullet points. Bullet point number 1 is I've been working with front-end stuff recently, which is pretty cool. I'm not your typical front-end person, but I've been having fun. There's a library called deeplearn.js, which is also the URL if you want to check it out online, to do browser-based machine learning. And no, the answer is no, I don't want to train my deep learning models in the browser, but I do want to do inference passes in the browser. Right. So we're building a little demo. I'm building a little demo to actually Steve. I think Eirik knows Steve Purvis. So the two of us are building a thing to recommend credit cards to bank users.
Yeah, I know Steve.
Yeah. He's he's an expert. Obviously, he knows front end, back end, middle end, upside down end, whatever. He knows everything. But I'm just beginning my front end explorations. And this is a cool place to start. So, bullet number 2. What was I saying? Oh, yeah. This is kind of cool. I was just working on this 5 minutes before the show, so I thought I'd mention it.
This seems like a random string of words pulled from the dictionary.
Do you want to read it? You want to read it and guess what it means?
Okay. Formulating alternative optimization strategies, parens, autograd, for fulfillment chains. Okay, right. So fulfillment chain, that sounds a bit like another way of saying supply chain.
Okay, you got it.
Sort of upstream supply chain. Alternative optimization strategies. Yeah, cool. So optimization of the supply chain. But with alternative strategies, which are being formulated by you.
Wait, you forgot the one word though, autograde.
With autograde. You'd say autograde, would you?
Yeah, because it stands for gradients, automatic gradients.
Okay, I would say grad though. Wouldn't you say shorten gradient to grad?
No,
I mean, I hear what you're saying. It's like the lib-lib thing, I guess.
Do you say relu or relu?
I don't know, relu. I wouldn't say relu. I'd say relu.
Okay. Well, there you go. There's your answer. Anyway.
What are you up to?
using automatic gradients is a thing related to our conversation from last episode with Ethan Rosenthal doing recommender systems with automatic gradient calculations. And I'm applying a similar related idea to traditional optimization workflows. And they just happen, in this case, to be working with supply chains. So those are my bullet points. What's up with you?
Nicely. Well, I guess time depth conversion is one of those things that I feel like will never die, no matter how often I think about it or write code for it. Or it seems like there's always some different or new angle, and when I try implementing it in the way that I've done things before, it breaks everything. It's one of those things where I'm starting to get renewed appreciation for, well, the only depth conversion tool I've ever had much familiarity with is Landmark's Depth Team Express from way back in the day. I doubt it even exists anymore. Awesome tool. You could give it basically velocities in any kind of format. So this is for doing conversion between sort of seismic time and well depth, let's say, in the subsurface. Because obviously those domains need reconciling if we're going to make any kind of useful predictions about things in either domain. And yeah, it's just a really sticky problem because we get velocities in all sorts of different formats, and they need to be calibrated in various ways, and they have different datums potentially, and you may want to convert things which are from outside of the range for which you have velocity. So you're doing extrapolation, and everything's sampled at different rates, and maybe sampled irregularly, and maybe defined with a combination of functions and data. So basically, it's like all the nightmare subsurface stuff wrapped into one problem.
Awesome.
Anyway, yeah, it's great. I guess what spurred me into that was partly some teaching stuff that we're doing. I was trying to make a nice demo, and I also got an email from someone who I like and respect very much, Chris Liner, about the time depth conversion stuff in Bruges, which turns out to be, I don't know, broken or insufficient in one or more ways. So anyway, I've got back into that, and now I've got a headache more or less permanently. So in Michigan next week, I'm teaching on my own. And then in Houston, I'm going to be downtown for a week right before Easter. So if there's any software undergrounders out there, undergroids, Evan and Diego and I will all be around. So let's hook up. I know.
Cool. I'll drive over and come see you.
Perfect storm. Oh, that'd be awesome. Oh, and okay, so we're doing a hackathon on data visualization of subsurface data, hopefully even some VR, AR stuff. I've probably mentioned it before. This is the one in Copenhagen in June. I've got a tricider.com survey out there where you can see the proposed projects for that hackathon and contribute other ideas if you wish, and or vote on the ideas or comment on the ideas that are already there. So there's a link in the show notes. There's also my Twitter feed recently. You can go check out those ideas. There's something like 20 there now. And some of them are pretty cool. There's one thing in particular that I urge you to Google right now, called cinematic rendering, which I believe is an invention of Siemens for their CAT scan data sort of thing. And it's totally remarkable. Like, it looks awesome. Basically, these images, you ever seen that? I can't remember the name of that German artist that does the sort of plasticized bodies as an art form. You can go and visit his exhibition. It's called Body Worlds, I think. It makes data look like these Body Worlds stuff. So realistic coloring, shading, textures.
How does it colorize the images?
It must be some kind of model, I don't know, that's been trained on anatomical images of some kind. It's totally amazing.
It's amazing.
It's beautiful stuff.
And grotesque.
And sort of grotesque, kind of amazing. And yeah, I would just love to see seismic data with that treatment. So that's my favorite visualization project right now.
That is pretty amazing.
It's probably like patented by Siemens, so maybe we'll all end up getting sued, but
I'm putting a link in the show notes. Write the lawsuit.
Okay, thank you.
Whoever's listening.
All right, that's all from me, man. Have you got anything else?
Cool. I'm nope. That's it. I'm fresh out of news.
In that case,
you know what time it is.
Let's meet Eirik. It's Eirik time. Hi, Eirik.
Hi, Matt. Hi, Graham.
Hello.
This is Eirik Larsen. Do you call yourself CEO, co-founder, president, kingpin?
All of those things.
All of those things. And accountant, lawyer,
accountant.
mailman.
Prince of Earth Analytics, a data science, geoscience / subsurface data science company in Norway. I'd say you're based in Stavanger, is that right?
Yes, we're based in Stavanger, so that's where the mail comes. Right now I'm in Bergen, so it's a 4-hour drive north of Stavanger, where we also have an office.
Nice. Is one of your colleagues based in Bergen?
Yeah, so I have actually 4 colleagues here.
Okay, nice.
In Bergen, in the center of town. So Bergen is the town where I grew up, so it's nice to come here every once in a while.
And cool. How is the winter weather in Bergen today? So I've only seen it in beautiful sunshine. Everyone always jokes about the rain, but I'm like, as far as I'm concerned, it only sun shines there.
Yes, today it does. And we have a bit of snow, blue skies. So we've had a beautiful winter with lots of snow and really cold winter.
Yeah, right. Yeah.
So in the hills, like 45 minutes drive from the office, we have 3 meters of snow.
Oh, awesome. Are you a skier, cross-country skier, telemark nut? What's your bag?
Yes, I have been skiing a lot. Unfortunately, this winter is a lot of work to do, so missing out a bit, unfortunately. But I've been into cross-country, telemark, and these days, when I get the chance, I do this, what we call a randonnée.
Okay.
What's that?
Alpine skis with some very lightweight bindings with fixed heel.
Mm-hmm.
So it's a tradition from the Alps that we kind of adopted here like 15 years ago. Mm-hmm. Before that, everyone was doing telemark.
Sure. Cool.
Very cool.
So how many people... You guys have been... Sorry, go ahead, Matt.
Sorry, it's just, there's a little bit of lag in the line today. I'm not sure where it is, but go ahead, Graham. You were going to ask something more relevant than me.
I was just going to say, so there's 4 people in the office where you are. How many people are in Stavanger?
In Stavanger, it's just me. And we have 4 people in Athens, Greece.
That's cool. How did that come about?
Yeah. So the whole Earth Science Analytics story, it's interesting, but basically I started on my own. I'm a sedimentologist, very much a geologist by background, and was working in exploration in oil companies. Basically had this feeling that we're not doing as well as we should be doing when it comes to predictive geoscience. So I started looking into ways of dealing with that kind of problem. I realized that these prediction tasks that we need to do in exploration and other aspects of petroleum geoscience, they are very often kind of multi-dimensional regression and classification problems.
Yep.
Which I'm not able to do in my head very well. We drilled some dry wells and some non-commercial discoveries, and some successes. So there's a lot of ups and downs. So that brought me into exploring statistics in the beginning. Figured someone had to have solved these kind of problems before. So, and I think it was 2015, and that kind of led me into learning about machine learning and AI. So, just totally randomly, I basically went skiing with my friend Besard, who was one of the other co-founders. And we were talking about what we were doing and so on. And he was working on machine learning with some seismic and electromagnetic problem, together with Dmitry, who is the third co-founder. So we just decided to team up and combine what I was doing with the wells and what they were doing with seismic and EM. And then we also invited the fourth co-founder, who you know very well, Chris Jackson.
Right.
And founded this as a company, to do it as a company and do something more out of it than a hobby.
Yeah, cool. So what are you doing?
What are we doing? So I saw you put a link to my GitHub account, which is not very informative. So that's one of the things I'm not doing, putting things there. But we did share something in this machine learning contest.
Right.
So I guess you can navigate to that repo. And that's more than a year ago, isn't it? And you know, right. it was about facies classification from well logs. So that's a useful use case. So as a sedimentologist, I've kind of hand labeled wells before with facies.
Yeah, right.
Obviously, that's prone to making mistakes, in addition to being terribly boring. So it's an obvious one to solve. And you can do it complicated with large facies classification schemes with many classes for academic problems. But for applied petroleum geoscience, maybe you can break it down to fewer classes or even just do lithology. So that's one of the things we have been doing. And so it's a classification problem. I think we've been exploring the space pretty well with all sorts of machine learning tricks. It was a really good effort by you, Matt, launching that contest. So they exposed many kind of approaches to the problem.
Yeah, really. Yeah, we're hoping to do another one really soon. It's just taking a lot of time to sort the data out.
Yeah,
unfortunately. But yeah, it was a fun way to bring a lot of just find a lot of people as well, right? Find this sort of community of people who are interested in this stuff.
Yes, indeed. Yeah, it was neat to see all the different approaches to solving the same problem. It's a goal of mine pretty soon here, within the next month or maybe 2 months, to put together a comparison of libraries. So rather than doing different methodologies, do different toolkits on the same problem and see what the performance differences are and the sort of effort required is between libraries. Kind of academic, but just for my own edification, and maybe write a blog post out of it. So that would be cool.
Yeah.
So
nice.
Other than lithologic classifications, it sounds like ESA's got a bunch of knowledge base and personnel power and experience in EM. Are you guys doing anything in that space? Anything in the seismic space?
Yeah, in seismic, not so much on EM. But Besard and Dmitry published a paper on that work that I did, combined EM and seismic in geophysics, 2016.
Yeah, cool.
But we are working on on seismic, definitely. But there's one other well-based approach that we're doing which is a regression problem to quantify properties such as porosity, permeability, source rock properties, and so on. And when we have that in place, including those lithology and facies classes in the wells, we basically have lots of information in the wells.
Yeah.
And in exploration, when you need to predict something, typically it's not in the wells, but in between the wells.
Right.
So obviously the seismic comes in handy. So we've done this kind of rock and fluid property prediction from seismic, initially using inverted seismic as the feature set. Which
I see. And so you tie the wells to the inversions at certain points and use those as your labels.
Use the inversions as the features, and the labels you can get from the wells.
Yeah.
Which is handy because you can train the models on the elastic properties in the wells and do the inference with the cubes. But it has definitely some limitations since we are not the owner of lots of inverted seismic.
Yeah, of course.
But in Norway, we have this national data repository, which is really useful. So it's not total open data. You have to be a member, but it's you can manage, any company can manage to pay for that membership. But it's not. It's a bit stiff for individuals. But that gives us access to more than 6,000 3D cubes.
Wow.
There's full stacks, partial stacks, all the wells that are more than 2 years old. So we do have lots of data to play with. But inverted seismic is not abundant in that database.
Yeah.
So the next step was obvious to try and see if we could go to the source of the inverted seismic, to go to the partial stacks. So we tried that out and presented some results last week. And basically, it was yesterday in Oslo, and 2 weeks ago in London in the Janet Watson conference on that work.
How did the results look? Did it come out okay?
Yeah, it comes out okay. It's useful, and so we'll keep on working on optimizing it.
Are you doing sort of like a 1D pass or something? Like you extract individual traces from the inversion and then you predict across many traces?
When we start with the partial stacks, we use simply them as the feature set, and we train on some form of ground truth for the rock property that we're interested in.
Right.
And as I guess you have experienced, that's a major part of the challenge, to obtain large and high quality label sets.
Yeah.
To train on.
Yeah, of course. Yeah, I ask because I'm wondering if the output, if the predicted volume or piece of a volume is continuous, or if it's kind of choppy. In the predictions that I've done on volumetric data like that, we tend to get like jittery characteristics in the output because you're moving across data that is presumably to the algorithm non-continuous.
Yeah, because you're doing it on single traces. Yeah, I don't know the details about that. I should have introduced myself better. I'm the geologist, and I did make a big effort to try and get up to speed with the coding, which I'm still working on, but I'm not a kind of coding superhero yet. So started with Octave, then MATLAB, and now Python.
Good.
But I'm just I can fiddle around with scikit-learn, play with that, and the pandas.
Yes.
But the key to making useful things for geoscience for me was to team up with people who actually know more about how to do this efficiently, like Dimitri and Socrates and Vangelis in Athens.
Of course. Cool. Are you so what's the target? Are you exploring? Are you selling upstream exploration services?
Yeah, so we've been selling services for a year now. And one of the clients allowed us to make the results public. So that's the one that we're presenting around various conferences.
Right.
And we'll write it up sometime before the summer. So you can see there is you can find it online, the slides. So it's a kind of paints a picture of what we're doing, and
cool.
In terms of services. And we're trying to make it more interesting than simply selling a to B mapping problem solving. So if you can stack up multiple A to B mapping solutions, like wireline log to facies, wireline logs to rock properties and to fluid properties, and all this, you obtain all this information about the properties that we actually care about, and not those proxies that are what is actually measured in the subsurface. Then we can start stacking this up into composite solutions and do things like prospect evaluation and play screening, things like this in exploration. And we have, some of us have worked a lot in exploration, so we did projects for exploration companies in the start, but the data is the same whether you're in field development or production. So if we can move on to including dynamic data from production histories and so on, that's an interesting way forward.
Very cool. It sounds like you're doing some fascinating work. What's the next step, do you think?
Yeah, there's so many next steps. One thing is that we got this research grant from the Norwegian Research Council just before Christmas. Very nice Christmas gift.
Yes.
And that is specific to the seismic related applications. So it's got two main parts, and where one is related to the interpretation of the seismic, the horizons, faults, and geobodies. The other part is related to this rock and fluid property prediction. So it's more in line with what is done in inversion and rock physics today. So that will be a major effort, and I'm working with getting industry sponsors to fund the remainder of the budget for that project. So we'll go over 3 years. And then we have this well-related stuff going on, of advancing that further on the side on our own money. And I think we have like five oil companies that we're doing services for right now.
Awesome. That's excellent. Is it enough? How much are you? How much is research and how much is work? I mean, are you trying to build a lot of scientific papers? Are you trying to bootstrap the thing through operational revenue? Or do you even have a sense of that yet?
We're not spending a lot of time writing papers. We'll try and publish this one study that we did for a Japanese oil company called Moeco. So that's committed to do, but it takes time to write these things. So,
of course, yeah.
And So far, we are just funded by the revenue that we get from these projects, and we're doing R&D and kind of paid problem solving in parallel.
Right.
And I guess we have to. This space is nowhere near fully explored, so
Of course. Yeah.
if you stop developing, then you're quickly left behind.
Cool. Yeah. I playing the old build a product through consulting services game. That's excellent if you can do it that way, right?
Yeah, and hard work.
Yeah, of course.
So we are also working on getting some VCs on board, venture capital.
Oh, nice.
So we are working on a fundraising. Hopefully, close it before the summer.
I assume that those VCs and people related to them are interested in funding product-based businesses. Are you able to say publicly yet what the product is going to look like, or do you know?
Yes, I am able to say that we are going to launch a product that will do geoscience problems, where machine learning is a central component, but only one of a large number of components. We are working towards launching this coming summer.
Cool. That's coming up fast, huh?
Yeah. So we have had a product in-house for a year, or slightly more. At the end of 2016, it was up and running. So we're continuously improving that and using it ourselves for these consultancy projects, which is a useful way of doing it, I think, because when you use your own product, you get to experience the bugs and the kind of non-optimal solutions. And since we have the development guys in-house, it's quick to get things fixed.
Excellent. That sounds great. I'm sure that you probably already know about this, but I don't know if you've talked to Lucas Mosser. He's doing some machine learning stuff in the upstream space, and they have some really neat ideas about performing inversion and through domain transfer and things like that. Yes. So if you haven't talked to him yet. Oh, you did?
Yeah. Yes, I did. I met him at the Janet Watson conference in Burlington House the week before last. So I know they didn't publish any code for this domain transfer, but I've seen their presentations, and that looks like an enormously interesting thing to get into.
Yeah, indeed it is. It's a whole new way of approaching the types of problems that geoscientists and all remote sensing experts have been working on for many, many years. Maybe hundred of years. So it's fascinating stuff, and I am excited to see the product when it comes out.
Yeah, I'm happy to come and talk about it in the summer.
Awesome.
I'll try not to be too specific about the date online.
Okay, cool. Well, we'll keep our ears out for that, and we will make an announcement when it happens, because I know that Matt and gang are likewise interested to see everything developing in this space.
Yeah. Are you guys working on some products as well?
Matt,
yes, Matt. Yeah, I mean, most of the tool set that we use for the sort of day-to-day, we try and put into our open source tools, for sort of data munging and that kind of thing. We have we're getting a little bit of traction for a proposal for a product that we'd like to build, or at least I'd like it to exist. I guess I'm not totally convinced that I want to be the person to build it yet, but and then I'm actually the thing I keep peddling at people is the thing that we already built but had to mothball. Pick this, which I just really want it to come back. It didn't have a business model, which doesn't help. But I had to take it offline because it was costing me a fortune to run it, unfortunately, but just because of a bug. We screwed up something to do with the caching, and we were just getting hammered by database calls.
Wow.
And I turned it off kind of in a panic. And, you know, I just can't face going back into the code base now because it's been over a year. And you know what it's like. 2 weeks of flailing just to make one change. So for now, we're completely swamped with training, which is, I think I've talked about before on the show, but has been a bit weird because we weren't really pushing that business, but it's also really fun because you get to meet a lot of people and help a lot of people. So we're kind of neck deep in that at the moment. And so any engineering we're doing is sort of just towards that. So it's sort of low level simplification of things rather than building tools. But I wanted to ask you more about this Janet Watson conference, because I think a lot of people, obviously we weren't there. I'd have loved to have been there, but we couldn't quite justify it. I suspect a lot of other people around the world would have liked to have been there but missed it. It was a couple of days, was it? I saw that the YouTube like a playlist just went up with many of the talks, something like 20 talks on it. I'll dig the link out and put it in the show notes. But what was it like? It sounds like it was pretty good.
Yeah, it was really great. I love those kind of single topic meetups where everyone comes for the same reason, and you know, good discussions in the breaks and in the bar in the evening, not to speak of that. But we had, it was actually two topics, because one was the virtual outcrops, and the other one, what they call broadly digital transformation, which includes many things, but there was lots of things going on in machine learning. We had a few of those talks on lithology, facies from well log classification. I think three of those. Yeah, mine was in this case study, play evaluation and prospect evaluation in the Barents Sea, which is a multi-component composite study. And Statoil, John Thurman from Statoil had a very interesting talk on, we knew they were working on something, but they were very silent for the last 2 years, I think. And at the Janet Watson conference, they presented their progress on seismic interpretation with deep neural nets.
Cool.
So I hope that one was recorded. I'm sure many would like to see that.
Yeah, definitely.
Yeah, right. I didn't look down the list yet, but I keep hearing people mention that talk, and someone has tweeted a slide from it and so on.
I think he did approve a publication of the talk. I certainly did for mine, so anyone who can find the stamina can watch it on YouTube.
Yeah, there's quite a few, that's for sure.
In a Norwegian English accent.
Cool. We should post the link on this show notes.
Yeah, I just put it in.
Oh, good.
But I don't see John Thurman's in there.
No, it's hard to get approval from oil companies. So.
Yeah, of course. Of course. Cool. So there's a question in here from Matt that is particularly, we asked this of a lot of our guests, but this one is particularly interesting considering your insight and now experience with actual paying customers in this space. And the question is, so the way that Matt posed the question is, what really hard problems are you looking forward to solving in the next decade? And I will add the additional, which of those problems do you think are actually tractable?
Yeah. For the next decade, that's a long time.
X years. You pick X.
Yes. Yeah. So I think we've seen a lot of progress on these basic tasks where you identify a feature set and a label set, and you find some function that maps between the two, and then you do your inference. So that basically works as alternatives to many things that we do in petrophysics, rock physics, and inversion that we discussed, with also the approach by Lucas Musser and the GAN stars. So I think we will see very quickly that those kind of problems find solutions that will be implemented in the daily business of the early adopters of the old companies. So we have our solutions to those problems kind of in place and working on optimizing them. But we don't have to wait until they are fully optimized. We can already start to stack these things on top of each other to solve these composite problems that I mentioned. Like exploring entire plays and prospects, and identifying all the properties you need to know something about, like the reservoir properties, the source rock properties. And I think we'll want to do more progress on doing this rock and fluid property prediction in not in a deterministic way, but in a probabilistic way, so that we quantify the uncertainty that will always be there, and the risk of that there is no reservoir at all, and things like this.
Right.
So I think it will move very fast, and that we will see solutions for these composite problems. And those things that we see that many people have got solutions to right now, kind of the low-hanging fruit, are those tasks that are basically solved well with maths already, like petrophysics. You have equations that help you today. But when you get into those problems that geologists have been dealing with, because we don't have physics solutions to those problems. And it's not to say that geology is harder than physics, but the problems are basically so hard. And that's part of the reason why we don't have any kind of equations or very quantifiable ways to solve them. So, but these things need to be solved in petroleum exploration and development production. So I think we will see that we'll start to attack those too, and that's where I think it will get really, really hard to do geology in a machine learning assisted way.
Interesting. Yeah, I'm excited to see what's going to happen in Salt Lake. We have this hackathon coming up in a couple months, and this is I don't know what the attendance is like, though I should probably go over that with Matt. But I'm excited to see sort of the more mature evolution of ideas in the space, right? So people have been kind of thinking about this now, so like you said, Eirik, since about 2015, and I think that in this May, we're going to see some really fascinating projects coming up, solving very hard problems using probabilistic modeling and stochastic methodologies to work on geology problems. I don't know, Matt, what do you think?
Yeah, I mean, yeah, I'm interested to see what happens in May too. I hope we get some stuff around stratigraphy in particular.
Right.
You know what? I guess one of the tricky things that we struggle a bit with in geology is that it's not necessarily clear when you've got the right answer, and even what the answer should look like. So, you know, it's just going to be interesting to see how people define problems and models when perhaps the cost function is difficult to actually write down. I'm really interested in some things like, I guess, the sort of stuff that we do. Like a lot of what we do is really just part of a kind of workflow. It's part of a chain. Like you look at something like horizon interpretation, and we're not necessarily interpreting horizons because we care about the shapes of the horizons. It's just that they help us figure out the next thing, right? They help us figure out the shapes of traps or the lithology of something, and so get to the bit where we actually do prospect identification or risking or what have you. And so I'm really interested in, like, when you take something like you know, inversion on a 3D volume. I mean, really, in principle, the result of an inversion, of a 3D seismic inversion, should be more useful than a bunch of horizons that you've interpreted. The horizons is really just a hang up that we have because we like making maps. And so we have this kind of analog-based workflow based on maps that we're sort of implementing right now digitally by picking lots of 2D sections and then putting the pieces together into to make a map. But we don't, like I say, we don't really need the map. And if we've got an inversion, that should be the answer, especially if the inversion is actually been transformed into, like Eirik said, some specific rock property that we really care about, like saturation or porosity or whatever. I mean, maybe there's a workflow where you don't even bother with horizons, as you just pick prospects out of 3D space and do the geobody thing that we've been failing to do essentially for the last 20 years.
Yeah, that's a very interesting comment. If you watched the video of my talk last week, see, third last slide, there's a picture of a porosity cube that was the output of, yeah, I guess 2 stacked machine learning models. So we get that porosity cube, but we get many other cubes related to rock and fluid properties. And they are basically the content of our geomodels, that standard geomodels that one makes in Petrel or RMS or whatever. We did a study in the Barents Seas, north of Norway, where you have the Triassic just below the seabed. And there's large impedance contrast between the reservoirs and the surrounding mudstones. So that output was super crisp. You see the architecture of the fluvial system and how the porosity is distributed around those channels and point bars and so on. So we asked ourselves, do we really need the interpretation in order to make the geogrid? You can just grid it up for the purpose of producing the runtime on your simulation or whatever. But you can grid it any way you want. But obviously, in other parts of the world, the data quality is not that good. So maybe you want that interpretation part done anyway to then address things in a more probabilistic way. But I think there are places around the world where you basically can bypass the whole interpretation step.
Yeah, I think there's even a sort of the corollary, if you like, in the seismic imaging world, I would say would be, I think we have talked about this before on Undersampled Radio, but you know, do we really need seismic images?
Right.
I mean, we've got all the datas in the shot records. Maybe an AI can get what we need directly out of the field data. We only process seismic really so that a geologist can look at it and go, oh yeah, there's a fault and this looks geological and now I know where I am in the stratigraphy. We don't actually need the image, maybe, for the sort of subsurface prediction we want to do.
That gets back to Erik's idea about stacked solutions, right? So the ultimate digital transformation, if you want to call it that, is you just shoot shot records, you just set off these air guns or whatever, and nobody ever looks at the data. they just input it to a black box, and the output is drill it location XYZ, and you're done, right? But there are many steps in between. And the idea is, if you take each one of those steps as a singular layer in a stack, can you hierarchically build up a system which removes layers from that stack? For instance, if you build a system which interprets horizons, which enables velocity volume conversion, then you build a system next week or whatever that takes out the necessary step of building the horizons, and then you can just swap these modules in and out as you move along.
Yeah, well, they're basically all hidden layers, aren't they? Right now,
yep.
They're all each one of those products is like a hidden layer in some gross neural network.
Humans are the hidden layers. The interpreters, the specialists are the hidden layers.
Maybe that would be the best outcome. Is those products are still generated, or something interpretable. It's like what we were talking about with Ethan, right? Whether these latent spaces are interpretable or not. I mean, it would be a cool outcome scientifically if those, the units inside those layers were produced interpretable byproducts if we wanted to interrogate them. But yeah. And if they don't, like, I'm quite interested in the idea that, if a latent space is not interpretable, then what is it about the way that we interpret things which is not efficient?
Yes. Yeah, good idea.
Yeah, I mean, I think there's all sorts of fascinating. So I hope we get to some of those questions. I feel like those are quite mature questions, and maybe we've got a lot of other really gross things to sort out first. Like, what does a well log actually measure, and what's the, like, there's so many questions around the measurement of subsurface data. Like, I heard I can't remember where this was, but somebody said, we think of well logs as like the direct measurement on the rock, and seismic as being some kind of remote sensed thing. But really, in some ways, it's the other way around, because seismic sees the undisturbed in situ physics, whereas the well log sees this kind of molested version of the Earth where we've drilled into it, pumped fluid around it, and there's a massive tool sitting right against the rock. Do you know what I mean? Like, it's not in situ at all. So
the mud invasion, the cavings, washouts.
Yeah, the hole conditions and all. Yeah, exactly. I mean, even core. I remember as a sedimentologist, I came into sort of looking at core thinking, well, finally we get to see the actual rock. And actually you get this stuff which is all kind of broken, or, it's been flushed with mud, and the fluid's gone, and and you don't quite know what depth it came from and which bit of the log actually corresponds to. I mean, there's so many problems with all of our data that I'm just like, how do we correlate any of this?
Yes. So I think I said machine learning is kind of the core of the product that we're launching, but you need to address all these problems too. Otherwise, it just runs wild and you can't trust it. So you need to build in solutions for shifting the core. Core is on driller step, the logs are on logger step, and it's not the same. And take care of the hole conditions. So it's an enormous amount of kind of convenience software that you need.
Yeah. Time depth conversion to bring it back
to solve math problems.
Yes, so you're going to make the inference and the seismic that used to be time. So a lot of things to solve. And also, I said, maybe we can bypass the interpretation step, but that's in these few fantastic examples, you may be able to do that. So we did actually decide to do the interpretation bit as well. And we will be presenting it in Salt Lake together with your colleague, Steve Purvis.
So, that's right. I forgot about that at APG.
We have a talk on fault interpretation.
Cool.
Right. That's going to be a good one.
To hear it. Yeah.
And we'll join the hackathon. Looking forward to that.
Of course. Do you have a project in mind?
We were discussing it earlier, so we'll keep on discussing it. But
All right, let me implant an idea.
Yeah.
So this is a project that I've been that's been on my back burner for 2 months now, and I may use as my hackathon project, which is, can we predict the evolution of a meandering channel using a recurrent convolutional neural network? So I'm going to try to gather some data for this before the hackathon. And if I can do that, it might be my hackathon project.
That's a point. Actually, has Zoltan signed up? I should check.
I do not think he has. Matt, it's that time of the show where we have to do that thing about reading.
Oh, awesome. Yeah. So what